Hey guys, welcome back. Today we are gonna study a new chapter that is periodic classification of elements. So, what are elements? Basically, whatever you see around you, they're all made up of elements. Though we use these things, we may not be aware of which elements they are made up of. But do we know that how many elements are known till date? At present, 118 elements are known to us. All these have different properties. Out of these 118, only 94 are naturally occurring. Now, as time passed, we started discovering many elements, and then scientists gathered more and more information about the properties of these elements. To study these elements, they started looking for some pattern in their properties, on the basis of which they could study such a large number of elements with ease. Now they had to make order out of the chaos. We have been learning how various things, all living beings, can be classified on the basis of their properties. Like in class 9th, we studied that living beings can be classified into plantae, animalia, and the further divisions. Even in other situations, when we come across instances of organization based on some properties, we look at some examples like in the shops, soaps are kept together at one place while eating items or biscuits are kept together elsewhere. Even among soaps, then there are bathing soaps, there are washing soaps, they are also kept separately. Similarly, scientists made several attempts to classify elements according to their properties and obtain an orderly arrangement out of the chaos. The earliest attempt to classify the elements resulted in the grouping of the then known elements as metals and non-metals. Now we know that metals are like iron, aluminium, copper, silver, gold, etc. And non-metals are what? Diamond, carbon, oxygen, the air which we breathe, in that the oxygen is a non-metal and it's so essential for our life. So later further classifications tried out as our knowledge of elements and their properties increased. Now there were different scientists who tried to classify elements. Mainly we will study about three scientists: Daubernier, Newland, and Mendeleev. Now let's come to Daubernier's triads. In the year 1817, now I am talking about the 18th century, when elements were not known as many as we have today. So in the year 1817, there was a man, a German chemist, Johann Wolfgang Daubernier. He tried to arrange the elements with similar properties into groups. He identified some groups having 3 elements each. Now 3 elements means triads. So he called these groups triads. Daubernier showed. Now what did he show? He showed that when 3 elements in a triad were written in order of increasing atomic masses. Now see, increasing atomic masses means that, for example, if there are 3 elements A, B and C, there are 3 in number, so they are forming triads. So if we write them as in the order of their increasing atomic masses like A, B and C, so Daubernier said that the sum of the atomic masses of A and C divided by 2, or else we can say the arithmetic mean, or we can say the average, will be the atomic mass of element B, which is in the middle. Now let us take an example. Take the triad consisting of lithium, sodium and potassium. Now what is the atomic mass of lithium? It is 6.9, and if we round off it will be 7. Sodium's atomic mass is 23 and potassium's atomic mass is 39. So what is the average of atomic masses of lithium and potassium? Do comment in the comment section. So how does this compare with the atomic mass of sodium? Now coming to the answer, the atomic mass of lithium is 7, potassium is 39. So when we do the sum, 7 plus 39 comes out to be 46, and when we take out the average, that is divided by 2, we get 23. So wow, that's an amazing thing. So I'm showing a table of Dobbernius triads. He found only 3 triads, which means he could only arrange 9 elements, he could only classify 9 elements on the basis of this property. Now let us come to the limitations of Dobbernius triads. Now the first limitation was that his triads only, he had only 3 triads from the elements known. First was this, and the second one was that the remaining elements, they couldn't be arranged in the form of triads. Now coming on to Newland's law of octaves. Now the attempts of Daubeney had encouraged many other chemists to correlate the properties of elements with their atomic masses. So Newland was also such a chemist in 1866. I repeat, 1866. At that time there were only 56 elements. At this time, John Newland, he was an English scientist. He arranged the then known, that means 56 elements in the order of increasing atomic masses. He started with the element having the lowest atomic mass, and which is that element? It's hydrogen, and ended at thorium, which was the 56th element. He found that every 8th element had properties similar to that of the first. He compared this to the octaves found in the music. Now what are octaves? Some may say that don't know, so let me tell you. Octaves are the notes of the music, like do, ra, mi, fa, sol, la, ti, and after that the same note repeats after the 7th note. Even in our Hindustani music, we have sa, re, ga, ma, pa, dha, ni, sa. So the sa and the sa is same. So therefore he called it the law of octaves. It is also known as the Newland's law of octaves. Now in Newland's octaves, the properties of lithium and sodium were found to be the same. Now at that time, let me tell you, there were no noble gases. So it was hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So here, due to the absence of noble gases, the periodic table was not as same as we see it today. They did not have neon, they did not have any other noble gases. So after lithium, the 8th element was found to be sodium, and by his luck, the properties matched. So sodium is the 8th element after lithium. Similarly, beryllium and magnesium resemble each other. A part of the original form of Newland's octaves is shown. Now let us come to the limitations. See, every chemist, every scientist has some or the other limitations. So the limitations of Newland's law of octaves was that the law of octaves was applicable only up to calcium. After calcium, every 8th element did not show similar properties to that of first. Let me tell you, light elements are the elements up to calcium. So this law of octaves did not work after the light elements. It only worked well with the lighter elements. The second limitation was that it was assumed by Newland that only 56 elements existed in nature. So he thought that only 56 elements will be there. There will be no elements in the future. There will be no scientists coming in the future. He was such type of a man, and he thought that no more elements would be discovered. But later on, several new elements were discovered whose properties did not fit into law of octaves. Now coming on to the third limitation. In order to fit elements into a table, Newland adjusted 2 elements in the same slot, but also he put some unlike elements under the same note. Now see, here many similar elements were kept far away and many dissimilar elements were kept together. I don't know why did he do so. Now if we note that cobalt and nickel are in the same slot and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. Now iron, which resembles cobalt and nickel in properties, has been placed far away from these elements. So with the discovery of noble gases, I said that at that time noble gases were not there, but with the discovery of noble gases, law of octaves became irrelevant. So his hard work became a waste. Thus, Newland's law of octaves worked well with the lighter elements only, and I said that lighter elements are the elements up to calcium. From hydrogen to calcium are the lighter elements. So we will continue with Mendeleev's periodic table in the next video. Till then, tata, bye bye and take care.